Okay, this is going to be a video about comparing the different types of roots a quadratic function has. What I want you to do is go ahead and write these 3 problems down in your journal and graph them on your calculator. Make a quick sketch and decide if each graph has 2 real zeros, 1 real zero, or no real zero, and therefore 2 complex zeros. Okay, so at this point you should have graphed all 3 of these. If you didn't, pause the video and let's take a look. So the first one is x squared plus 4x plus 4. Too many pluses. And when we look at a graph of that, we see that it touches the x-axis 1 time. So my little sketch is just going to look like this. It has 1 x-intercept. So this one has 1 real 0. All right, so now I'm going to type the next one in. X squared plus 2x minus 3, hit graph, and I see it crosses the x-axis 2 times. So I'm going to say 2 real zeros. And that last one is x squared plus x plus 4. Oh, and it doesn't cross the x-axis at all. So it has no real zeros or roots, but 2 complex. And what that means is if I were to take that equation, set it equal to 0, and use the quadratic formula, whatever number is under the square root would become negative, and I would have I would not have real x-intercepts. Right, so what I would like you to do is I would like you to please turn to page 89 in your packet. Looks like this. And we're going to make a couple little corrections. First off, where it says b squared minus 4ac, I want you to graph. That's the first correction I want you to make. The second correction I want you to make is here where it says 1 double rational root. I want you to cross that off and just write 1 real root, or 0. Here, I want you to write, where it says 2 different radical roots, I want you to just write 2 real. And then this column you can just kind of cross off completely. And then no real roots, I want you to write above that 2 complex roots. All right, so what we're going to do is we are going to, instead of imagining these equal 0, we're going to imagine they all equal y or f of x. And what we are going to do is we are going to graph each one of them, and we are going to determine if there is 1 real root, 1 real 0, 2 real roots, 2 real zeros, or 2 complex roots, no real zeros, by looking at the graph and determining its x-intercept. So for example, this one's already got the check for 2 real roots, and we see that if we graph that, it's going to cross the x-axis 2 times. So boop, boop, there's my little graph, and that's why I have 2 real roots. So go ahead and type in number 2. And when we press graph, we see 1, 2. And now it's like the vertex is way low on that parabola, but that's okay. We see, crosses twice, 2 real roots. All right. So there is 1 correction I want you to make at the very bottom. Number 16 says plus 14. Right here, see it? I want you to change that to plus 4. So what I want you to do is, I'll do a few more with you. Go ahead and graph them and we'll determine the real roots. So let's do number 3. So again, you can always pause the video if I'm going too fast. Minus 8x plus 4. And when I look at the graph, I see 1, 2 real roots. Here's my graph. And now we'll do number 4. 2x squared. Oh, so I see that one does not cross the x-axis at all. So it has no real roots, but 2 complex roots. Let's do 2 more. So we've got 4x squared minus 12x minus 30. And graph it. And 1, 2. 2. And now we'll do one more. Oh, that's kind of nice. All I have to do is change that to a +9. Plus. Ooh. So now that one looks like it's only going to have 1. See how like the vertex just touches the x-axis like that? Okay. So go ahead and finish the rest of this page on your own. So at this point, if you're still watching, you should be working on this on your own. Pause the video. I am going to give you a little, I will check off the correct boxes, but you need to work on it on your own. I'm not going to fill in the little graphs, so you need to do that. Oh, whoops, this one's wrong. This is 1. This is 1. This one is going to be 2. 2. 2.